Hello, my name is Unglaub, and this is how to calculate the projection W of x along y. So in my standard xy plane, I have here a vector v, which has some magnitude, and it's also separated from the x-axis by this angle theta. When I do a projection along each of these axes, I end up with two orthogonal vectors, vx and vy, such that I can rewrite my expression for this general vector v as the magnitude vx times the unit vector I plus the magnitude vy times the unit vector j. Now, if I want to compute what these components are, I have to first understand what the magnitude of the original vector is. And that's given by this modulus of v, and hence by using Pythagorean theorem and a bit of geometry, I have vx is equal to the magnitude of v, the hypotenuse, times cosine of the angle theta. And likewise for vy, I have the magnitude of the vector times sine of theta. Now what we're interested in is determining what the projection W is of the x-axis along the y-axis. So one way of thinking that in terms of this framework is if our vx vector was infinite in magnitude and lied purely, of course, along the x-axis, and then I want to compute what is the inner product of that with the y-axis. So to do this, I have W, which is going to be the projection onto the y-axis, since that's what we're interested in. So the W is going to actually be Vy, and this is simply going to be the magnitude of V, which in this case is Vx, times sine of the angle theta. But you'll notice that if my vector lies purely along the x-axis, that the angle theta is going to be equal to 0. 0 degrees, or alternatively 0 radians. Sine of 0 is equal to 0. Therefore, my projection, the shadow of this x-axis, this vector that lies all along the x-axis, onto the y-axis, because they are separated by 90 degrees, we call them orthogonal, and we calculate the projection to simply be 0, because the angle between the vector that lies along the x-axis and the x-axis is 0. So this is our projection W. My name is Unglaub, and this is how to calculate the projection W of x along the y-axis.